Welcome everyone. So this is our 64th live stream geometry. We have 3 people here with us so far. And today I'm going to do 3 problems from the Vietnam IMO training in 2021. They were just sent to me recently and they look like really nice problems. And then the other 3 I'm going to take from the journal Comal. So I did a few from that journal last time. It's a Hungarian journal. And so I'm going to do 3 more this time. So if you want to join us in the future, feel free to email me at mgreenb801@gmail.com. It's in the description of my video. We meet every Sunday at 8 a.m. US Central Time. All right, so with that, I'm going to get started. So let me share my screen. Just a second. All right, here we go. So here's the first problem that was sent to me. I'm not sure if it was in this order. And yeah, I haven't had time to put the problem in LaTeX yet, but here it is. So we have the triangle ABC. It's in a circle, it's in circumcircle O and has orthocenter H. And M is the midpoint of arc BAC. So I'm going to draw the orthocenter H. All right. Triangle center ABC4. And now I will draw the midpoint of arc BAC. Let's call that M. I'm just going to label the midpoint of side BC, just in case I want that later. And the line through O, so O is the center. Parallel to AM. So AM is the external angle bisector. And then, so we draw the parallel through O to AM. And it meets HM at point P. Interesting. And then we project P onto all 3 of the sides. That's interesting. Let me see. Can P ever? Yeah, let's do it like that. That looks a little better. So I wonder if this almost looks like a parallelogram right here, but I don't. HM isn't necessarily parallel to AB, so let's see if I can make it kind of like that better. And then I'll draw the 3 perpendiculars. This almost makes me think of isogonal conjugates because we have the 3 perpendiculars. So X, Y, Z. X, so it's Y, Z. Yeah, this looks a lot like isogonal conjugates. We want to show that the circumcircle of XYZ passes through the midpoint of HM. So let's draw that midpoint. All right, and now I'm going to hide some stuff. Let me see if I can hide a bunch at once. Hide. What did I draw this? Oh, that's right. Okay, so I want to draw OP, then PX, PY, PZ. Might as well draw this. And E is the midpoint of HM. All right. We want to show that E lies on that circle. I wonder if D lies on that circle too. It almost looks like it. Yeah, so the midpoint of BC, it looks like it also lies on that circle. So do we have isogonal? I wonder what the isogonal conjugate of P is.
I think the isogonal conjugate, it must lie on the line DM. Because
the isogonal conjugate of P lies on the line, DM.
Yeah, because B is a, so let's say the isogonal conjugate is P prime, then the projection of P prime onto BC must also lie on that circle. So in other words, P prime must lie on DM.
Yeah, no, that's true. Hey, Sardar, thanks for joining. So yeah, basically we want to show, yeah, so let's draw the isogonal conjugate of P. See how I should do this. Actually, let me draw the midpoint of arc BC. Because what I'm going to do, let me shrink the diagram a little bit. ED also lies on the 9-point circle. Oh yes, yeah, by homophily. So E and D do lie on the 9-point circle. That's true. Okay. So let's see. Why did I not draw HP? Oh, where do I why would I draw
Isn't it given in the problem? Is on HM.
Oh, you're right. Yeah, I should have drawn it. No, that's my bad. Yes. Why did I want to draw that? Oh, I wanted the isogonal conjugate of P. So basically, here's the angle bisector A. If I reflect P over that, or actually, I want to reflect this ray over it. So reflect about line. So this point right here should be the isogonal conjugate. But we have to prove, I mean, really, I'll just define this to be P prime, and we want to show that it lies on FM, basically.
How did we define P prime?
Yeah, I'm just defining P prime to be the isogonal conjugate of P. So then we want to show that it lies on MF. So I think the midpoint of PP.
We need to prove that XP is angle bisector of ZXY. If we prove it, then we can prove that P prime is on ME, I guess. Is it E?
Or F?
F.
Interesting. Right. So PX is the angle bisector of ZXY? Or we want to prove that?
Yeah, we want to prove it.
Interesting. Geo King asks, is P prime the orthocenter of MBC? I don't think so. Let me.
It will be actually. We discussed this before.
Oh, really?
Yeah.
Oh, yeah. This is, yeah, we've seen this idea. So,
maybe we can first select the orthocenter of MBC and then try to prove it.
yeah.
Try to prove that they're isogonal conjugation.
Yeah, I kind of like it. So I'll draw the orthocenter of MBC. So we could, let's call it K. And then we want to show P and K are isogonal conjugates.
We know that A prime HKM is a parallelogram. We proved this before.
Yeah. So yeah, A prime HKM is a parallelogram. I'm going to hide the circle for now.
Did you prove that B is on the circle?
That D, no, I did not prove yet that D is on the circle. So the maybe it's worth drawing the midpoint of HK, because I think that would be the center of this. Well, actually, no. Let me make sure that's true. I'm pretty sure it's true, but I just want to check. Yeah. All right. How did this become an A prime? I just wanted to say A. I think I need to do this. That's better. So I guess once we show that P and K are isogonal conjugates, then it would make this a little easier. Because then yeah, we could draw the perpendiculars from K to AB and AC, and then we want to show that circle passes through point E. Yeah, E is defined as the midpoint of HM. So for example, let me draw the perpendiculars. So step one is to show P and K are isogonal conjugates. And we can calculate, yeah, how do we do that? So angle KAC is angle KAM minus angle CAM. And then maybe an angle chase would do it from there. Because KAM
Let's intersect HK with BC.
HK with BC.
Yeah.
And we know AE and K are collinear, right? Because it's a parallelogram. So I'll just leave it something like that. So that'll be point G.
Then BDOE is cyclic.
Okay. GDOE. We also have this. Yeah, it's not obvious to me why it's cyclic. It's from Taiwan PST. Okay. So angle KAC is KAM minus MAC. And KAM is AKH. Actually, let me sorry, you can let me know if the figure is too complicated, but sorry. All right, so let's try to prove that XP bisects ZXY. Kind of looks like Blanchett's theorem, right? In fact, I think there's a certain generalization of Blanchett's theorem, right? I forgot what it was. But maybe we could use projective geometry, because that's the same as saying xg, xz, xp, xy is harmonic. So yeah, what's the good thing to project those onto? You can try projecting it onto MF. So XP goes to infinity, XG goes to D. Oh, that's just the same as, yeah. You can define P as the isogonal conjugate of K, and then prove that PO is parallel to AM. That's an interesting idea. Because yeah, we haven't really used that fact. Okay. So yeah, I'm just going to leave the names the same. So if we did that, let's call it P prime. So then we would know they have the same pedal circle. We just wouldn't know yet. We don't know yet that E lies on it. Okay, and then we want to show, I can delete G. All right. Oh, that's true. We wouldn't know yet that it lies on HM. So we need to show that that lies on HM. And also that PO is parallel to AM. Yeah, and if we know it lies on HM, then since AMKE is a parallelogram, that would solve the other, well, would it? It might. Yeah, it is interesting. Wherever you move A, the isogonal conjugate of K will lie on HM. Yeah, this circle looks like a generalization of the 9-point circle. Let's see, does the midpoint of AH lie on the circle? No. Because yeah, that would lie on the 9-point circle. So the center of the circle is going to be the midpoint of P prime K. So P, H, and M are collinear. So basically the isogonal conjugate of K is the intersection of HM with the parallel through O to AM. That's really interesting. There's a lot going on here. Yeah, I don't know too much about isogonal conjugates. That's the thing. Let's see. Thanks for joining, VJ. So we're on the first problem. So yeah, AHKM is a parallelogram. So how do we use that fact? Are AHK and AP prime O similar? Ah, interesting. Yeah, because H and O are isogonal conjugates and K and P prime are. So and we know G is the midpoint of KP prime. Oh, can I check? Yeah, I'll check. $68.03. Oops. Made it the other way. Yeah, it looks like it. Oh yeah, maybe it is the isogonal line lemma, because yeah. Because yeah, PH and OK, we want to show that they meet at M, but PO and HK, PK and OH. I'm trying to remember how to use the isogonal line lemma here. So
how do we define K?
so K is the orthocenter of MBC, and P prime is the isogonal conjugate of K. So yeah, showing that P, H, and M are collinear is equivalent to showing that OP prime is parallel to AM. Yeah, so we just have to show one of the two and then we prove the other. It's kind of interesting. So which do you think is easier to prove? P prime O is parallel to AM or PH and M are collinear? I kind of like P prime O is parallel to AM because then we can get rid of point H, right? We prove the similarity AHK is similar to AOP prime. Is that true in general when you have like two isogonal conjugates like that, or not necessarily? Oh, I think we saw, okay, it's not true in general, but it's true in this case, right? Like, yeah, it's true in this case. I think they're the same. Oh. Yeah, because they're the opposite direction, that's why. Yeah. Good point. Oops. AO. Yeah. AHK is similar to AOP prime, yes. I'm not sure. Let's see. So we want to show AH. P prime is defined to be the isogonal conjugate of K. So can we show AH over AK is AO over AP prime?
I think if we can prove that AHK is similar to AOP prime, then it is done. We can prove MH and B prime are collinear.
Okay. If we can prove that they're similar.
Well, actually, I think no, because by defining P prime this way, we don't know that OP prime is perpendicular to AF. Because in the original point P, we have AM parallel to OP prime. So Yeah.
But the thing is, once we show, if we can show that P prime, H, and M are collinear, then by the isogonal line lemma, it follows that P prime O is parallel to AM.
Oh, okay.
Yeah. So we want to show AH over AK is AO over AP prime, right? Is it obvious that the pedal circle of K passes through the midpoint of HM? I'm not sure that that's that obvious. Oh, ABCK. So the Poncelet point, you might be right. So that's the intersection of the 9-point circles of all those triangles, right? Interesting. So basically you're saying the 9-point circles of is that true?
It's another property of Poncelet's point.
Okay.
It passes through all lines, all midpoints of the lines connecting a point and the orthocenter.
Interesting. One sec, guys, I'll be right back. All right. So yeah, I guess we want to use that KB equals DF. Or we could just use that this is a parallelogram. So I think I want to use that angle MBP prime as angle CBK. I think so. Let's think about that. Angle ABP prime is angle CBK, which is 90 minus angle MBC. Okay, so basically if I draw, let's say I draw the antipode of C. Then angle ABP prime is equal to angle CBM. So let's think about what that means. So that means AB and BM are isogonal with respect to C prime BP prime. Is that right? Yeah, they're isogonal. Okay. I don't know if I can use the isogonal line limit again. Well, it means ABP prime is BMF, which is BAF. Yeah, it looks like yeah, so if I reflect a yeah, that'll meet there. Yeah, I think the problem, what makes this hard is So the isogonal conjugate, we know that AK and AP prime are isogonal, but how do we use that BP prime and BK are isogonal? I'm not sure a good way to do that. But we have to use that fact somewhere. If we're gonna do it this way. K is the orthocenter of MBC. What do you want to do a chase on? So yeah, we know a lot about point K. It's just the thing with P prime. We know that we know that P prime AB is KAC. I think that's what GEO King said, or maybe, I'm not sure who, maybe Khan said it, that if we know those are similar, then those are collinear. Okay, so if we define P the way it was originally, then we have AEH. Do you mean AFH, or what's E?
The midpoint of HM.
So APT. Oh, T is the antipode of A. Okay.
I think T is L in this case, in your diagram.
Okay. Reflect. Okay, so let's call the antipode of A T. Okay. A. So we have POT. MAH is similar to POT. So you have a couple properties. So let's define P the way it was originally. I think you mean ADH is similar to APT. Well, I'm not sure. So HD and T are collinear, right? ALP and APT. ALH and APT. Interesting. ALH and APT. Okay. Also MAH and POT. So if MAH and POT are similar, then that means that these are parallel. Oh yeah, but we're given that in the problem. Yeah, if we define
It shows the two sides. ALH and A prime T are similar if and only if AHK and AP prime O are similar. Just ratios.
Oh, so first of all, are you defining P prime to be the isogonal conjugate or the way it is?
Isogonal conjugate.
And then it's just proving they're similar is just ratios?
No, proving the similarity of ALH and AP prime T are similar if and only if AHK and AP prime O are similar. So
Okay.
this doesn't change anything.
Yeah, I see what you're saying. Because yeah, L would be the midpoint of AK and O is the midpoint of AT. Yeah. Right. But yeah, I think we're eventually going to have to use the angle CBP prime is 90 minus. So we eventually need to use that CBP prime is BMF. Oh, you know what? BC is the angle bisector of P prime BF, I'm pretty sure. I think that's going to be really helpful. Oh, actually, now I'm not so sure. Is that true?
No, it's not.
Okay.
Can you recall it? Say it one more time.
ZB prime is A over 2. So P prime BX cannot be A over 2.
Yeah. There. Wait. AK, HK, and AOP prime are similar. Okay. We have to use something about this being the isogonal conjugate besides just these two angles being equal. See what I'm saying? Yeah, so if we define P prime the original way, yeah, we need something more about this other than that angle CAK is BAPP. We need like that, yeah. Is BK perpendicular to ZX helpful? I think it could be. because then that would mean if that were true, is that what you see? BK is perpendicular to ZX?
It's well known because they're isogonal conjugates.
Oh. Yeah. AH over HK equals MK over HK, which is MO over OP. Wait, how do we know MK over HK is MO over OP? Oh, if we define it the original way, okay. Equals AO over OP. And angles are the same because OP is parallel to HK. And okay, so that would mean the two are similar, right? AHK. Okay, so then we would have those are similar, and then we could use the isogonal. Yeah, once we know those are similar, like if we define P the original way and we prove they're similar, then does that show K and P are isogonal conjugates? Okay, so I'm trying to think about this. So yeah, we know that AP and AK are isogonal. And then how do we show that BP and BK are isogonal? Whoa, Poncelet's porism? Or the Poncelet point, I think you mean, right?
Yeah, it will be Poncelet's point.
Yeah.
I think I have shown that D lies on the circle. By defining the original way, I think the rest, like actually I almost prove it, but the rest I don't think it's really hard because, okay, just let me present it, okay? So we're gonna define P the original way it is.
Okay.
So by a common lemma, if we can prove that XP is the angle bisector of YXZ, then D must lie on the circle, right?
Okay.
So in other words, I'm gonna find a way to calculate angle PXY.
Okay, angle PXY.
What PXY is equal to PCA.
Mm-hmm.
So later I have said that we have the two triangle APT and ALH are similar, right?
Yeah.
You connect TP.
Yeah.
So I'm gonna label the intersection of CH onto AB. Let's call that point maybe
We'll see what it is.
yeah, we'll see what it is.
M.
So noticing that we have ALP is similar to APT, right?
Mm-hmm.
And we also have AHN is similar to ATC, right?
ATC. Yeah. So did you say ALP is similar to AHC? I think so.
I'm saying AHN and ATC.
Yeah, those I agree are similar. Yeah.
We have the whole quadrilateral ANHL and the whole quadrilateral ACTP are similar, right?
ACTP and ANHL. I think yes, I see it.
So we can calculate angle ACP now. It is equal to angle ANL.
Okay, ANL.
So we know that PXY is equal to ACP, right? So we have PXY is equal to ANL.
Okay.
So similarly, we can show that PXZ is equal to AY. Let's call the intersection of BH and AC.
Yes, sorry.
Let's label that one. I think
Q.
it's Q, right? So similarly, we have AQL is equal to ZXP. Just keep using the similar quadrilaterals. We
Okay.
calculate AQP. I mean AQL. It is equal to ZXP.
AQL is ZXP. So ANL and AQL are the two angles, right?
Yeah, so we need to prove it is equal. And we can just like delete all the points and just keeping like the HM and Q and
Yeah.
N.
So basically, if L is the midpoint of HM, then we want to show that AQL is ANL, right?
Yeah, so then we will have the XP is the bisector angle bisector, and then we have D less than the circumcircle. We can just delete all the points and saving the.
Yeah. So do you know how to let's see.
I haven't tried it yet, but I think it will not be hard because we just keep like 5 points or 4 points, so it will be easy.
Yeah, no, I agree. So let's hide a whole bunch of stuff. Oops. Yeah, we can hide a lot of lines. See how this looks. Oops, sorry. Now, let me just hide the rest one by one. So um, Okay, so sorry, I see the chat. There's a couple people. So we want to show that AQL is ANL, right? I see someone else joined, by the way, Sevet Honor or Sebket. I think this might be your first time, but thanks for joining. Whoops. So LNA, this is driving me crazy. It used to always do the acute angle. I wish they changed it back to that because I almost never do obtuse angles. So we know L lies on the 9-point circle, right? So LNQ we know is the 9-point circle. Yeah, I think that might make it easy actually, because LNQ is the 9-point circle. So ANL, let's see.
Can you draw AH?
Yeah. So ANL is RNL.
Yeah, if you figure out it lies on the 9-point circle, then you just angle chase, easy angle chase.
Well, so we know L lies on the 9-point circle because it's the midpoint of HM, and a homothety about H takes the 9-point circle to the whole circle.
Oh, well, good. So we can prove it. Yeah, angle chase, easy. So back to the original problem, we got the circle passing to midpoint of BC. That's all I got.
So let's see, how do we angle chase it? So angle LQA. So we want to show it's LNR, right? So LNR, that's LQR. So we want to show LQR is LQA. Is it? Let's see. Let me draw that part right here. Oh, because RV. So RV we know is parallel to BC. So we want to show angle L. So RNL is R. Now I'm confused again. It's probably easy, right? It's equivalent to LR equals LV. Okay. And that's true because L is the midpoint of HM and RV
because L is the midpoint of HM, noticing that MUSH is a
trapezoid.
so yeah, and trapezoid with HS is perpendicular to BC. So LS must be equal to LU.
Oh, and then from there, LR would have to equal LB. Okay. So, all right. So once we do that, Then we know, okay, so I'm going to undo a whole all right. So let me add back in everything. Okay, so that means that we know that PX bisects angle ZXY, right? And from there we know and then that proves that P and K are isogonal conjugates.
Yeah. It does. It does.
And then
also X, D, Y, Z is equal to.
So yeah, that shows that X, D, Y, Z is cyclic. And is it obvious that
We're done now.
we're done?
We know that isogonal conjugate of P is on AK and also is on MD. So K is the isogonal conjugate of P.
Okay. And
So
then
from Poncelet point.
by the Poncelet point. Okay, there's a lot of stuff here. I'll probably just write an outline of it.
Wait. How do we know that in final we need to prove that XYZ pass to the midpointing? Like how did we do it, Seda?
Is that the Poncelet point? The Poncelet point idea, ABP equals ACP implies.
Oh yeah, I haven't learned about Poncelet yet. I don't know if you can recall it from.
So on DM. Okay, so let me do this step by step, and you guys can fill in the details. But first, yeah, there was just so much stuff in the solution; it's confusing. So, all right, we have. So we define P like in the original question, right? And then, so first of all, let K be the orthocenter of MBC. So we have angle PXZ is angle PBZ. And PBZ was LNA, is that right? I forgot the proof. Okay, first we need to prove APTC. Okay, so I'm gonna write those two. Okay, so APTC is similar to ANHL, and ATDP is similar to AHQL. All right, I'm gonna fill in the proof of this later, but let's assume that that's true for now. Because yeah, I remember you mentioned it, because ACT is similar to ANH, and so yeah, let's just assume for now this is true. And then the next step is ATP, is that ABP is similar to or angle ABP equals angle AYL. So we have angle PXZ equals angle PBZ is ANL. Yeah. And then similarly, angle PXY equals angle ANL. And then, so then we have NLQ and D lie on the 9-point circle. I'll just write it like this: is the 9-point circle. And so then by an angle chase, ANL equals angle AQL. And that implies that XP bisects angle ZXY. And once we know that, that proves that P and K, does that prove that P and K are isogonal conjugates once we know this?
Actually,
We also need the similarity of AHK and APO.
Okay. So, and that's kind of from what Khan wrote earlier. I think so. So Khan, so he did a couple of ratios earlier. So I'm going to copy that. So is this kind of the proof that okay. I think this was the idea that he wrote, right? So this proves that AHK is similar to APO. So then by some angle chasing, so yeah, just because we spent a while on this, I'm gonna and then so L is the Poncelet point of ABCK. Yeah, Poncelet point, the proof is a little bit long, but so I'm not going to write out the whole thing here. But yeah, Wikipedia has an article on it. So let's see. So the Poncelet point of ABCK, it's the intersection. So the 9-point circles of ABK, BCK, ACK, and ABC all intersect at one point. So let's see. So if you look at ABK, L lies on the Poncelet point of that because L is the midpoint of AK, or L lies on the 9-point circle of that. And then ACK, it lies on the 9-point circle of that. And then BCK, we want to show it lies on the 9-point circle. So For ABCD, it is the midpoint of the segment connecting them. Yeah. I'm just going to leave this like this for now. So XYZ passes through the midpoint L of HM. All right, I'm going to move on to the next one just because we've spent a while on this. But if you look up Poncelet Point on Wikipedia, I think you should be able to find it there. Let me just move this up. Yeah, this was a good one. So yeah, I think it's almost 10:30, but I'm glad that we went through it because I feel like I learned a lot.